All right, so it's part 2. We're going to learn about simplified radicals. All right, so far, you know how to simplify things, yes? If you have, 10 eggs and 2 eggs, you can put them together in a carton, and that's a dozen eggs. If you have a piece of pizzas, you can put them together, and you can fill the box of pizza, right? That's simplification. Same with radicals. Sometimes we have radicals, and we can multiply them to simplify them as we see fit. Well, as per rule of math, of course. All right, so let's start with what we know. We have square root of 4, and that is 2. Square root of 8. Notice I'm not talking about cube root of 8. If it's cube root of 8, it will be a 2. What is the square root of 8? We can try to estimate that, but we are looking for a radical expression rather than a decimal expression. All right? So how do we go about doing that? Someone knows? What is it? Do you know the answer? No, it's not. Okay. So I'm going to write my answer as radical mixed with integers. So again, if you're still facing computer, make sure you turn around. All right. So we know that a is equal to 4 times 2. Yes? So if we have square root a, we can say square root 4 times 2. And this could be further written down as square root of 4 times square root of 2. And we know square root of 4 equals to 2, correct? Yes? Therefore, we can say 2 times square root 2, or simply 2 square root 2. Make sure to write this 2 big and not a small 2 tucked inside, otherwise it will mean just part of the square root. So far, so good? Yep. All right. So what about if I start with square root 4 times square root 8? What does that mean? All right. So if I could if I can go this way, right, to split my single square root into 2 square roots multiplied together, the reverse is also true, right? I can write it as 4 times 8 in there, okay? And I could further reduce it by finding its, what? Well, I know square root 4 is 2, so I'm going to keep it there, okay? So 4, and this 8 is equal to what? 4 times 2, yes? And therefore, I'm going to split this into square root 4 times square root 4 times square root 2. And in fact, I know square root 4 is a 2, and therefore I can write it 2 times square root 2, or simply 4 square root 2. Okay, so this is more of a computation thing rather than understanding. There's no units here. So as long as you know how things compute, we are all good. So that's an example. That's another example. All right, down here, one more example. If I start with 4 square root 2 times 2 times square root 8, what would I do here? So notice that 4 square root 2 is identical to 4 times square root 2 times 2 times square root 8. I'm going to multiply the integers first, and then I'll deal with the radicals later, all right? So I'm going to take 4 times 2, I know that's an 8, times square root 2 times square root 8. Well, what is square root 8? Well, from here, I know square root 8 is 2 square root 2. Yes? We can go through that logic again, but since we already have it done, I'm going to write it over here. It's a times square root 2 times 2 times square root 2. Well, it looks like I have, well, here, let's deal with the integers first. So 8 times 2 give me 16. Square root 2 times square root 2, what is that? Do you guys know the answer? What's square root times square root 2? Okay, notice if I were to draw a square like this, if the volume is 4, each side is square root 4, right? Yes? If each side is square root 2, then the volume, sorry, the area, if the area is 4, each side is square root 4. If each side is square root 2, the area would be 2. Does this make sense? Okay, we're going off what we know, right? So 2 square root times together will just give you a 2. The answer is 32. Takes multiple steps, but it's all based on what we know. All right, so that's the multiplying part. If you have square roots multiplying together, the strategy would be multiply the integers first. If the radical part, you can reduce it, and then maybe you can turn it into further integers. Okay? Can we move on with addition of radicals? Hello, we have a little bit of chatter in there, so if you can tune your attention towards the overhead, that'll be awesome. Thank you. All right, so next, let's add and subtract radicals. All right, add and subtract radicals. Now, if I have 2 centimeter plus 2 centimeter, what is that? Is that a trick question? 4 centimeters, thank you so much. Thank you so much. If I have 2 pies plus 2 pies, what is that? 4 pies. Yum, yum. Chicken pie. All right. If I have 2 square root 5 plus 2 square root 5, what do I have? So, see the square root 5 as a thing, okay? So I have 2 of this plus another 2 of those. I have 4 of those. Thank you so much. 4 square root 5. All right? If I have negative 7 square root 2 plus 10 square root 2, what would I have? So I have negative 7 of something plus 10 of something. I would have 3 of something. Thank you so much. 3 of something. Don't worry about what the square root number is. Just treat it as something. All right? So negative 3 plus 10 is 3 of something. Awesome. Now, what if I have 2 square root 5 minus 3 square root 6 plus 7 square root 5 plus 4 square root 6. Oh, okay. So you can see 5 as, I don't know, you can imagine 5 as apple and 6 as tomato, whatever. Okay, so let's add the 5s together, all right? So I have 2 of this guy and 7 of that guy. Means altogether I have how many? 2 and 7. 9, yes. 9 of square root 5s. And square root 6, I have negative 3 and positive 4. Negative 3, positive 4 give me positive 1. Is that correct? Okay, so it's just positive 1 or plus square root 6. And that's the end of the story. That's it. I can't further simplify it. No way. Okay. Let me give you somewhat a curveball here. 7 square root 2 plus 3 square root 8. you might be prone to thinking that, oh, I have 7 oranges and I have 7 oranges and 3 pineapples. I can't really add them. No, that's it. But remember that this square root 8 could be reduced, right? You see that? That square root 8 is actually 2 square root 2. 7 square root 2 plus 3 times, I'm going to write a little times there. That square root 8 is 2 times square root 2. All right? It's kind of have a hidden identity there, right? So please find out what it actually is. And then we have 7 square root 2 plus 3 times 2, give me 6 square root 2. Now I have 7 of something plus 6 of something. Yes? We have 13 of something. Following so far? Final example. Final example. If we have 7 square root 6 plus square root of 54, okay? Again, that 54 is probably have some hidden identity there. So let's borrow some space from here. 54, let's use prime factorization, our best friend here, to help us out break this Lego piece. Divide by 2, give us 27. I can't use 2 anymore. Divide by 3, give me 9. 9 divided by 3, give me 3. That's all its Lego pieces. 2, 3, 3, 3. Now notice that 2 and 3 give me 6, right? So I'm going to write this as 6, 3, 3. 7 square root 6 plus 6 times 3 times 3. All right? So notice that if I have 2 of this guy, I can take it out. Remember from last time. Okay? So this will give us 7 square root 6 plus 3 square root 6. Then I have 10 of the square root 6. And that's the end of the story. All right. I'm going to end the lesson there, and you can proceed with the assignment.